The last concept we're going to look at is called expected value. And expected value allows us to marry probability with some concepts of cost, if you will, and not just cost, but actually making some money. What are the chances we can make some money from this? What are the chances we would lose some money from this? And a lot of the examples that you'll see, problems that you'll see, will involve things like lotteries and raffles and things of that nature. So for expected value basically starts with a probability, and you multiply that times the cost for that particular occurrence. And then in expected value, there'll be other things that happen. For instance, if you buy a ticket, say, some kids at a school are doing a raffle for something, and you buy a chance on, whatever the prize is, you have a probability, a chance of winning, but then you also have a chance of losing. And so you have a chance of just losing your money. And so this accounts for that. So that other probability, we're going to call it probability of B, times its cost. And so we'll see that in our first example here, how that actually factors out. So our expected value on this first one, it says, suppose you buy one ticket for $1 out of a lottery of 1,000 tickets, where the prize for the one winning ticket is to be $500. What are your expected earnings? So you buy one ticket for $1 out of a lottery of 1,000 tickets. So your chances of winning are 1 in 1,000. Okay, so this is the probability of A, and we will multiply that times the cost of that particular probability or that occurrence. And there's really not cost with this. It's actually a good thing, at 1 in 1,000 chance that we're going to win $500. Okay, so that's our money. But also to factor into that, we have to be conscious of the fact that there are 999 chances out of 1,000 that we're going to lose our dollar. Okay, so this then would be what we would put into the calculator. So we'd have 0.001 times 500 plus 0.999 times -1. Okay, now you could put all this in the calculator for comparable fractions, or you could put this in. So I'm going to put this in my calculator, 0.001 times 500 plus 0.999 times -1. And I get, hold on, I actually shorted myself on a number, 0.001 times 500 plus 0.999 times -1. Expected value would be -50 cents. Okay, and I actually got 0.499 on that, but it's -50 cents. Okay. Number 14, suppose a charitable organization decides to raise money by raffling a trip worth $500. If 3,000 tickets are sold at $1 each, find the expected value of winning for a person who buys one ticket. So expected value, so our first probability, we have a 1 in 3,000 chance of winning, and that is a trip worth $500. And then if I have a 1 in 3,000 chance of winning, I have a 2,999 out of 3,000 chance of losing my dollar. So we'll take that, put that in our calculator. So I'm going to put these in as fractions this time, just to make sure it stays nice and neat on my end here. And our expected value for this is -0.83. So, or excuse me, 83, not 88. So for both of these, because the probabilities of losing our money is so great, that's why we ended up, our expected values on both of these are that we're going to lose some money. Okay, And again, this involves probability, so there is some theory to it, so it doesn't necessarily match up with it, with what we know as empirical, in that in this first, in number 13, we're probably going to lose our dollar. 14, we're probably going to lose our dollar. Chances are even better that we lose our dollar there. Okay, and so that's expected value. This can go out even further. There are other nuances to this type of problem that you could look at. But really and truly, the ones that we will do will just have two pieces of basically, the probability for, and then what you could expect to win, plus the probability against, and what you'd expect to lose.